objective for lesson 7 is I will represent measurement data with line plots. So we worked on the last lesson by looking at line plots and answering lots of questions about the line plot so you would understand what a line plot was. So we're going to be working more with line plots today and actually making some of our own line plots based on some measurement data that we are using. So you're going to have this piece of paper, this template in your binder where it says straw lengths and inches. So you're going to need that for this first part of the concept development. So if you need to push pause and get that paper in front of you and have that ready, do that now, please. So this is Mr. Hans's class draw data, and there we're going to use a line plot. So we first need to determine a scale. Just like we would do on a bar graph, we have to have a scale for a line plot, which is where we have all of the numbers and the tick marks for each number. So the first measurement on the line plot will have to be the smallest measurement on the chart. So you need to look at the chart and you need to find the smallest measurement. And I want you to circle what the smallest measurement is on your chart. So push pause and do that now. When you're ready to check it, you may push play. So the number that you should have circled was 2 3/4 inches. Now that we've figured out what the first measurement on our line plot is going to be, now we have to find what the last measurement on the line plot is going to be. So if we started with the smallest measurement, then we know that our last measurement has to be the largest one. So now I need you to put a square around the largest measurement so we know what's going to be the last measurement on our line plot. So in your chart, put a square around the largest measurement, and when you're ready to check that, you can push play. So you should have noticed that 5 inches was the largest measurement, and I put a square around 2 of those because there are 2 5 inches on the chart. So now we are going to look at all of the other data in the chart because we have to know what interval we should skip count by whenever we're using our scale. Like on some bar graphs, we would skip count by 2s or 4s or hundreds or tens, and on the other line plots that we looked at, there were some measurements that had 1/2 inches, some of them had 1/4 inches. So we've got to look at all of the other measurements to see what interval we're going to be using whenever we are plotting all of these measurements on our line plot. So when you're looking over here, I see that I've got 3 inches, 3 3/4 inches, 4 1/4, 4 3/4, and I'm looking over here on the rest of the part of the chart and I'm seeing a lot of other fourths, but I also see some halves. So like this is 4 1/2, I've got another 4 1/2, a 4 1/2, and a 3 1/2. But if you remember, whenever we were working with our ruler, that 1/2 is also equal to 2/4. So I could really say that this is 3 2/4. And I really could say that this 4 1/2 is 4 2/4. So we're probably on our line plot going to use the interval of fourths because all of these measurements have fourths, and we know that 1/2 is also the same thing as 2/4. So we're going to start making our line plot, and you're just going to make your line plot on this paper in your binder that has this chart on it. So you're going to use the line that's on the bottom of your paper. We know that the smallest measurement was 2 3/4 inches, so that needs to be the first measurement that you're putting at the first tick mark on your line plot, so you need to get that written on your paper. The next tick mark is going to be 3 inches, and the reason, like, if I were to keep going, I could put 2 4/4. But if you remember whenever we worked with fractions, that when you have the same numerator and the same denominator, that's equal to 1/2. So if I have 2 right here, and I know that 4/4 is 1/2, when I have 2 and 1 together, we know that that makes 3. So that's why we're not putting 2 4/4. And you see up here that there is not a 2 4/4 because that's really what 3 would be. So now we're going to start with our fourths again. So we're going to have 3 1/4, and we know after 1/4 comes 3 2/4. Then we would have 3 3/4, And then once again, you're not going to put 3 and 4/4. You're going to have 4. And then we're going to just keep going. And you're going to have 4 and 1/4, 4 and 2/4, 4 and 3/4, and then 5 inches, because we know that we're going to stop at 5 inches because that was the greatest measurement or the largest measurement. And we remember that 3.5 is also the same thing as 3 and 2/4. And we know that 4.5 is the same thing as 4 and 2/4. So it's okay if you put 3.5 and then 4.5 underneath those two measurements, because we know that up here on the chart we're not going to see a 4 and 2/4, or we're not going to see a 3 and 2/4. We're going to see a 3.5 or a 4.5. So now that we have made our line plot and we've plotted all of our measurements, we're going to start putting our X's on our line plot. So the best way to do this, so you know that you're getting everything on there correctly and you're not putting it more than one time, is to check off each measurement as you're doing it. And that's what this says right here, check off as we go. So you're going to put an X over each measurement based on what we're seeing in the chart. So I'm just going to start up here on the top row of the chart, and then I'm going to keep going through the rows. So I'm going to go to 3 inches right over here, and I'm going to put an X. The next one, since I'm done with that, I'm just going to cross it out. I've got 4 inches, so up above 4 inches, I'm going to put an X. I'm going to cross that out as well. Now I'm at 4.5 inches. Remember, you're going to see 4 and 2/4, but we know it's the same thing as 4.5. So I'm going to put an X over 4 and 2/4, or 4.5. Now I need to go to 2 and 3/4, which was the smallest one where we started. So we're going to put an X there. Cross that out. Now we're going to 3 and 3/4, which is right here. We're going to put an X over that, and then we're going to cross that out. So I'm going to let you go ahead and do the next 3 rows from the chart and plot your X's on your line plot. And whenever you're finished with that, you may push play so we can move on. So this is what your line plot should look like. I know you don't have blue X's and the red checks, but your line plot should look like this except for the colors. But just like we would do when we had a graph, we have to have labels. Usually when we make a graph or a line plot, we're always going by a chart or maybe a picture graph that we're looking at. And usually that chart or picture graph has a title already. So we're going to be labeling our title for our line plot by looking at the title that's on the chart. So the title on the chart says straw lengths in inches. We don't have to know in the title that it's in inches, because that's what we're going to be using to label something else. So the title for your line plot is going to need to say straw lengths. So go ahead and make sure you're getting that written on your paper as the title, because we know that each one of these measurements is the length of a straw. We always have to label underneath all of the numbers that we're putting on our line plot. So we know that 2 and 3/4 and 3 and all these other numbers are the lengths of the straws, but we know that they're in inches. So that's where the word inches comes from in our chart. All those numbers are inches. So you're going to label the bottom of the line plot inches, so that way we know what the numbers stand for. And then the last part is we have to label what each X is equal to. So you put X is equal to, and then I want you to think, what does each X represent? If we're looking at straw lengths, then what, if I look over here at 5 and I see 2 X's above 5 inches, then what do those X's represent? So we need to put that next to what the X is equal to. And what you should be putting is that the X is equal to 1 straw. Okay, so we're going to be answering some questions, and you can answer the questions either on the front side of this paper or on the back side of this paper, depending on where you have room. So just like we worked on in the last lesson, we're just going to answer some questions based on the line plot that you made. So the first question we're going to look at says, how many straws were at least 4 inches tall? So it's not just asking how many straws were exactly 4 inches tall. It says how many were at least 4 inches tall. So that means that we're going to be looking at 4 inches and also anything that's larger than 4 inches. So you're going to be looking at all of these measurements right here on the line plot because all of these measurements are, well, actually I need to take it back some. I need to start at the 4 inches and then go up to the 5-inch mark because all of these are at least 4 inches or more. So we're going to count all of the x's above 4 inches, 4 1/4 inches, 4 1/2, which is also the same thing as 4 2/4, 4 3/4, and 5 inches, and then we're going to see how many straws there were. So I want you to go ahead and do that and answer this first question on your piece of paper and push play when you're ready to check it. So when you counted all of the straws, you should have counted 12 straws that were at least 4 inches tall. So this next question, we're going to come up here to the top part of the screen. It says, which measurements happened most frequently? So the way that we answered this is we looked at the inches. So we're going to look down here at the bottom, and we're going to find the measurements that have the most x's. So whenever I'm looking, I see here's 3 x's and here's 3 x's. That's above 4 inches and it's above 4 1/2 inches. So that tells me that 4 inches and 4 1/2 inches happened most frequently because they have the most x's above them. The next question says, which measurements happen least frequently? So you're going to do the same thing here, but you're going to be looking for the measurements that had the least amount of x's. So I want you to look for those on your line plot, and I want you to write down the measurement in inches of the ones that had the least amount of x's, and whenever you're ready to check that, you may push play. So you should have noticed that 2 3/4 had 1x, and that 3 1/2, or if you wrote it down as 3 2/4, that would also have been right because those are the same measurements. But these two had the least amount of x's, which means that they had, there was only 2 straws total that were 2 3/4 and 3 1/2 inches long. So the last question that we're going to look at on this screen says, how many straws were shorter than 3 1/2 inches? So that means that we're actually going to be looking at straws that are shorter than 3 1/2 inches. So that means that I'm not going to start at 3 1/2 inches because it said that it had to be shorter than 3 1/2 inches. So that means I'm going to be looking at these 3 inches right here. So I'm going to be looking at 2 3/4, 3 inches, and then 3 1/4. Answer this question on your paper as well, telling me how many straws were shorter than 3 1/2 inches. And when you're ready to check that, you may push play. So when you counted, there's 1, 2, 3, 4, 5 straws that were shorter than 3 1/2 inches. Okay, so now we're ready for the problem set. So if you want to have that out and ready, do that now, please. So we're going to be doing exactly what we did in the concept development. We're going to be making another line plot. And up at the top it says Mrs. Weiss's class grows beans for a science experiment. The students measure the heights of the bean plants to the nearest 1/4 inch and record the measurements as shown below. Part A says uses the data to complete the line plot below. So it already has a space for you to write the title. So I think that we can probably go ahead and write the title because like I talked about in the concept development, when you're making any type of graph or line plot or chart, you want to look at what data you're working with, and the data that you're working with, that's going to be what your title will be. So since the title of this chart says heights of bean plants, that's what the title of our line plot is going to be as well. I want you to go ahead and write your title of your line plot on this line that says title. And if you remember back in the concept development, we're going to have to figure out what measurement is going to go first on our line plot. And the measurement that we find first is by looking for the smallest measurement. So I want you to circle on your chart on this problem set what the smallest measurement is. So that way we know what to put first on our line plot. When you found the smallest measurement, I want you to push play. Okay, so the measurements you should have circled were 1 and 3/4. And I wasn't looking very closely on this page because they actually already have the measurements on the bottom for you. So that's good for you. That's just another step that you don't have to do. I know that on the assessment that we do at the end of this module, you will have to do the measurements on the line plot on your own. So it is good to know how to put the measurements on this line plot. And right here where it says 2.5, I do want you to go ahead and write that this is also the same thing as 2 and 2/4. So that way when we're plotting measurements from the table, um, you know exactly if we had a 2 and 2/4 where that would go, because we know that this 2.5 could also mean that it was 2 and 2/4. So now I'm going to let you go ahead and start plotting all of the X's on your line plot at the bottom of this page. And remember, you need to check off these once you plot the X on the line plot so you're not putting those X's more than once. So go ahead and put all your X's on the line plot, and when you're ready to move on, you may push play. Okay, so your line plot should look like mine does. And we're not ready to move on to the back side of this problem set because we still have to put labels. We already have our title, but remember we always have a label for what these numbers are, and then we also have a label for what the X's are representing. So if you look back up at the chart, we knew that we were measuring the beam planes in inches. So just like we did on the concept development, we're going to be writing inches right here to label that our numbers that we have with the fractions on most of them are inches. And we know that each X is going to be a beam plant because we know that if I'm looking at, let's say, 3 inches, I know that there are 3 beam plants that are 3 inches tall. So we know that the beam plants are, and I forgot to put 1, so make sure you're putting 1 beam plant, and that's what the X's are equal to. So now we're going to be ready to move on to the other side of the problem set, and we're going to have to be flipping back and forth because this next side of the problem set is actually going to involve questions based on the line plot that we just made. So we'll have to flip back and forth. This says for part B, how many beam plants are at least 2 1/4 inches tall? It says label here, and it says X equals here. We just did that. We just labeled it, and we put what the X's were equal to. So I don't know what this means. It says what label are you looking at to actually answer this question. So I think right here we're needing to put 2 1/4. That's the one that we're going to be looking at. And then we're going to have to write how many X's were at 2 1/4. And that will tell us how many beam plants were at least 2 1/4 inches tall. And actually, since this says at least, you're actually going to have to look at 2 1/4 and all the inches that are greater than 2 1/4. So when we flip back at our line plot, 2 1/4 is right here. So we're actually going to be looking at 2.5, 2 3/4, 3, and 3 1/4. So we're going to have to write all of those labels down, and then we're going to have to put how many X's we saw to be able to answer this question. So we're going to have to go over here and we're going to have to write all of these labels or these measurements down. So we're going to have to add 2.5, 2 3/4, 3, and 3 1/4. I've got 2.5, 2, whoops, I need to have that a big 2, 2 3/4. And then 3, and then 3 1/4. And then we're going to put how many X's total, meaning how many beam plants were at least 2 1/4 inches tall. Okay, so going back down, I've got 3 X's here, 3 X's here, 3 X's here, and 3 X's here. You notice that I skipped 2 3/4 because that had 2's, The reason I did the 3, 3, and 3 because that's a strategy. You try to clump the ones together that you can, and I know that that right there is the same thing as 4 times 3, and I know that 4 times 3 is 12. So if I've got 12 with these groups of 3 and I add 2 more to that, I know that 12 plus 2 is 4. So how many x's there were for this one? There were 14 x's, so that tells me that there were 14 bean plants that were at least 2 1/4 inches tall. So the next question is asking how many bean plants are taller than 2 3/4 inches. Now I want you to notice it says how many are taller than that. So we're not going to be looking at 2 3/4 inches. We're going to be looking at everything that is taller than 2 3/4 inches. So we need to go back to the line plot, and we're going to find 2 3/4 inches, which is right here. So we're going to be finding the measurements that are taller than that. So we've got 3 inches and then 3 1/4 inches. And I see that there's 3 x's above the 3 and 3 x's above the 3 1/4. So that tells me that 3 and 3 make 6. So to answer this, there are 6 bean plants that are taller than 2 3/4 inches. Then we're going to be ready to move on to question D. So question D says, what is the most frequent measurement and how many bean plants were plotted for this measurement? So the way that we find the most frequent measurement is to find the measurement that has the most x's, and then we need to figure out how many bean plants were plotted for that measurement. So I'm going to let you go ahead and answer question D yourself, and then push play when you're ready to check it. So the correct answer was that there were 1 3/4 inches was the most frequent measurement, and there were 4 bean plants planted that were that height. So question E is asking, or it says, George says that most of the bean plants are at least 3 inches tall. Is he right? And explain your answer. So we've got to go look at all of the measurements that are at least 3 inches tall, meaning that they're 3 inches or more than 3 inches. And we're going to have to see if those measurements have more x's than all of the other measurements combined. So we're going to start at 3 inches and look at the measurements that are more than 3 inches. So here's 3 inches, and then the only other one past 3 inches is 3 1/4 inches. And I know between these and these, I only have 6 x's. And when I'm counting right here, I see that these two just have 6 as well. So that tells me that this and this and this still has to be added to 6. So that definitely tells me that 3 inches and 3 1/4 inches, or the bean plants that are at least 3 inches tall, are not more than all of the other bean plant inches combined, or bean plant heights combined. Then we have to be able to explain our answer and tell if he is right. So our first question that we have to answer is he right? So George is not right. And we have to explain, so we're going to put because the plants that are 3 inches that are, let me reword that. Because there are 6 plants that are at least 3 inches tall, and there are more than 6 plants that are, move this up, less than 6 inches tall. So these types of questions you really have to look at closely, because that was a lot of information that you had to look at to be able to answer question E. So a lot of the questions that we worked with on line plots they're pretty simple, but you just really have to make sure that you're looking at the information on the line plot correctly so you're getting the right answer. So now we're going to move on to the next question on the problem set. Something was wrong on my screen, so you're going to see how question F looks a little bit bigger because I had to make it bigger so I could cover up this other thing that was on the screen that didn't need to be there. So question F says Savannah was absent the day the class measured the heights of their bean plants. When she returns, her plant measures 2 2/4 inches tall. Can Savannah plot the height of her bean plant on the class line plot? Why or why not? So we need to look back and see if she can plot 2 2/4 inches. You know what? This is what we did at the beginning of the lesson, so this actually goes really good with this question because I already had you write 2 2/4 inches under 2.5 because we know that 1/2 is equal to 2/4. So yes, that means that she can plot an X right here above what is actually 2.5 because we know that 2.5 and 2 2/4 are actually the same measurement. They're just written, the fractions are written a different way because we know that those fractions are the same fraction. So to answer the question of if she can plot that, we can say yes, because 2 1/2 is the same as 2 2/4. And that's the explanation is as simple as that. You don't really have to put any more. That's why it's really important whenever you have the 1/2 that you realize that it's also the same thing as 2/4 because you may see this question again maybe on the assessment or another problem set that we have. So whenever you are doing the exit ticket, you're going to be making your own line plot. Make sure you're labeling the tick marks that aren't labeled and that you're putting a title. It already tells you what the X's stand for, but the numbers at the bottom of the line plot are not labeled, so you're going to have to make sure you put a label for that. And then you're going to have to put all the X's in the right spot. So whenever you're finished with that, you can bring it to me so we can go over it.